The universe, informally, means everything there is. Mountains and oceans and the moon and hot nuclear balls of hydrogen, and a whole lot more. But if the universe is everything, does that mean it includes the things that we don't know exist? Or even the things that we believe exist but haven't yet seen or observed? For example, is the future a part of the universe? In physics, we usually distinguish between these two notions of universe as 1. The observable universe, which is everything whose existence we've thus far been able to confirm or observe, or could in principle observe if we pointed our telescopes at it, and 2. The universe with a capital U, or the whole universe, which is everything that exists, has existed, or will exist anytime, anywhere, regardless of whether or not we're aware of it yet, or ever will be. Of course, the main reason for this distinction is so that we can talk scientifically about parts of the universe we haven't yet been able to observe. And the two biggest reasons we might not have been able to observe a piece of the universe yet are either it's in the future, or it's so far away that light from it hasn't had time to reach us. Yet. To explain, as far as we know, the universe had a beginning and is now around 13.8 billion years old. Light takes time to travel through space, so anywhere too far away from us just isn't visible yet, in the same way that thunder from a distant lightning strike isn't audible, until you wait long enough. If you were blind, the thunder would be the first sign you have of the storm's existence, though once you hear it, you can infer that the storm must have existed all along. So within the observable universe, what do we know exists? Pretty much just three things: space-time, particles, and the physical laws that describe how space-time and those particles interact to give rise to gravity and matter and forces and everything else. It's open for debate whether or not mathematics is a part of the universe or if it exists outside the universe in some sort of mathematical heavens. But if you think that mathematics exists, and if the universe is everything that exists, then, well, I'll leave that up to you. There's one other thing, though. You may have heard of parallel universes, or multiverses, an idea proposed by researchers or sci-fi fanatics that perhaps what we think of as the universe is actually just a small piece of a larger thing which is really everything there is. But that's another verse of the story. The universe. How big is it? Does it have a center? Does it have an edge? Is it getting bigger? And if so, why? Well, we know that there are two different meanings for universe. First, the observable universe is everything that we've been able to see or observe thus far. And second, the universe, or the whole universe, means everything that exists or has existed or will exist. More specifically, the observable universe is the region of space visible to us from Earth. And since the universe is only about 13.8 billion years old, and light takes time to travel through space, then regardless of what direction we look, we see light that's been traveling at most 13.8 billion years. So it's logical to think that the observable universe must then be 2 times 13.77 equals 27.5 billion light years across. But it's not. That's because over time, space has been expanding, so the distant objects that gave off that light 13.8 billion years ago have since moved even farther away from us. Today, those distant objects are a bit more than 46 billion light years away. Multiply times 2 and you get 93 billion light years, the diameter of the observable universe. To give you a sense of scale, the size of the Earth within the observable universe is roughly equivalent to the size of a virus within the solar system. Although that doesn't help much because we can't really appreciate the incomprehensible smallness of a virus nor the bewildering bigness of our solar system either. So let's just say that the observable universe is stupendously big. But the whole universe, as far as we can tell, is a lot bigger. Space is most likely infinite, or at least it doesn't have an edge, though the difference between those is another story unto itself. Now, what about the center of the universe? Well, the observable universe has a center. Us. We're at the center of the observable universe because the observable universe is just the region of space visible from Earth. And kind of like how the view from a very tall tower is a circle centered on the tower, the piece of space we can see from here is naturally centered here. In fact, if you want to be more precise, each one of us is the center of our own observable universe. But that doesn't mean we're at the center of the whole universe, just like the tower isn't the center of the world. It's the center of the piece of the world that it can see, up to the horizon. But just because you can't see beyond the horizon doesn't mean there's nothing there. And so it is with the observable universe. Looking up at the sky, we see light that's at most 13.8 billion years old and coming from stuff that's now 46 billion light years away. Anything farther is beyond the horizon. But each second, we see new, even older light coming from slightly farther away, 3 light seconds farther to be precise. And so our view of the cosmos is literally getting bigger all the time. All we have to do is wait and watch as the universe ages and light from more distant places has the time to get to us. So here we are, sitting at the center of our observable piece of the whole universe. How big is the universe? Well, the observable universe is currently 93 billion light years across. The whole universe is probably infinite. Does the universe have an edge? The observable universe does. It's 46 billion light years away in any direction. And the whole universe has a temporal edge, or what we call a beginning, but almost certainly not a spatial one. Does the universe have a center? Again, the observable universe does. The universe as a whole? Almost certainly not. And is the universe getting bigger? Yes, space is expanding, which makes both the observable universe and the whole universe bigger. Plus, over time, we see older and older light coming from farther and farther away, so our observable universe gets bigger that way too. And that, in a nutshell, is our view from the tower. You are the center of the universe, and so am I, and so is everyone else, and so is no one.
The universe is amazing. So if your friends ask about it, and they undoubtedly will at any social occasion worth being at, you'd better know your stuff. So, 3 minutes, 30 facts. Pens and pencils at the ready. The universe as we can see it is 46 billion light years across, but only 13.8 odd billion light years old, meaning that the only thing we know of that can go faster than light is the universe itself, because it stretches space as it goes. No one's sure what shape the universe is, but it could be a sphere, a flat plane, a half pipe, or even a trumpet. Some people even think it may be donut-shaped. And it's made up of a spiderweb-like structure of billions of galaxies in strings and clusters. Our galaxy, the Milky Way, and our nearest neighbour Andromeda will collide in 4 billion years, but only 4.6% of the universe is actually made up of atoms, or stuff. The rest is dark energy and dark matter that we can't see. And of that 4.6% that is stuff, over 90% of that is hydrogen. That hasn't stopped an entire star being made of diamond from being found, though. The 4,000 kilometre wide object 50 light years away is a hefty 10 billion trillion carats. The universe has actual gaps, though. The largest is the Boots Void, 250 million light years of absolutely nothing. The largest known object in the universe, though, is a group of quasars bound together 4 billion light years wide, so big it nearly breaks physics. But there's lots more stuff. The universe contains around 100 billion galaxies. The smallest contain just a few million stars, the largest can contain over 1 trillion, and that means there are probably some 300 sextillion stars overall. The largest star we know of currently is NML Cygni, which is 1,650 times the size of our Sun and would take light nearly 7 hours to circle. Incidentally, the Earth could fit inside our Sun roughly 1 million times. The Moon is a quarter of the size of Earth, however Earth weighs 81 times more than the Moon. Incidentally, Earth weighs this. The fat bastard. Speaking of planets, current estimates suggest that there is roughly one for every star in the Milky Way, or some 400 billion in our galaxy alone. Some 17 billion of those are thought to be Earth-sized, although we've actually only discovered around 900 planets. However, we only found the first one in 1988. One likely candidate for Earth-like planets is the star Gliese 667c, which has at least 3 large rocky planets in its habitable zone, and 2 more on the fringes. Busy. There are around 18,000 possible markers of other planets, though, including 262 that may be habitable, and we're only looking in a tiny weeny patch of our own little galaxy. And speaking of our tiny little patch, Voyager 1, our fastest current spacecraft, is about to leave the solar system after 35 years of flight, and after another 40,000 years it'll pass close to Gliese 445, and that star is moving towards us at 270,000 miles per hour. And finally, here's 5 more random bits of trivia that didn't fit anywhere else. The flags that the US put on the moon have all gone white through solar radiation. The deepest sound in the universe is a black hole in the Perseus galaxy cluster, which plays B-flat 57 octaves below middle C. We know of 4 dimensions, but the string theory of how the universe works predicts there are actually 11. When you tune in an old TV set and get snow, part of what you're seeing is actually the remnants of the Big Bang itself, and you are entirely made of the remains of an exploded star. Fact. Perhaps the most remarkable thing of all, though, is that we've managed to find all this out. So now you can impress your friends with your incredible knowledge of the universe, and they'll think you're a slightly less attractive, slightly less successful Professor Brian Cox. Good work, you.